Oh, and I don't. Or it's just, I realized.
Okay. So let's see, where did we leave off? Were we doing those midpoint ones?
Cliffhanger.
I think that's what we were on.
Yeah.
Okay, so when we were doing like M20 and M40, I wanted you to practice these. And I'm going to show you some calculator stuff you can use if you want. If you don't want to, you can count these out. Notice, there's going to be 40 rectangles there, so I don't want to count these out.
It was awesome.
Without my calculator's help, I don't want to do it. So let me show you how to do this with a calculator if you care to. It's up to you. So it's not an essential thing. But anyway, if we want to find the midpoint, remember we were going under this curve, right? It was between -1 and 3. And we had the exponential, which of course goes through 1. Looks something like that, yeah? We're looking at rectangles between there. Each rectangle, if we're doing M20, they're going to be really small, right? And we're going to take the midpoint, so let's exaggerate and say it was that big. That's really not, that's too big, right? Let's exaggerate and say the first rectangle was this big. We're taking the middle of that rectangle, and so forth. So how do we get all those midpoints? Remember, first we said, okay, first we got to think about the whole width. How wide is the interval?
2 to the 20.
It's 4 wide, right? Let's say how we got that again.
Yeah.
So 4 wide, and then we said how many rectangles did we want? 20, and that gives us how wide each rectangle is supposed to be. So last time we got that was 0.2, right? In this one, how wide is going to be 4 still divided by 40, so that's going to be 0.1. So you could either go -1 plus 0.1, and then that plus 0.1, and count those all out in your calculator. Let me just show you a fancy way to do this. Of course, what if that was 1,000? Then you can't really count it anymore, right? You're just going to be sitting there all day long. It's going to be terrible. Or what if it was 1,000,000? Then we could be doing it till the end of the year and we still not finished, right? Okay, so how would you do this with a calculator or computer software? Well, you know how to go to sequences. So let's go mode. You don't have to do this if you don't want to, but it's a nice thing. I'm going to change the mode from function mode that we're used to sequence mode. I think we have done this before. I perhaps didn't do enough of it with you last year. This guy's coming up. I've done a lot more of it. And then you go find the sequence thing. It was under second list. Fancy that. That's the same thing we've been doing. I think it's over under ops. See the sequence thing. So now I just want to build a sequence that outputs all those midpoints for us. Okay? Think about it. If you had 1,000 of them, you'd have to do it this way. There'd be no other choice. So what's a sequence that gives us -0.9 first? Or let's do it with the 0.2, shall we? How can we do that? So we want to start with -1, right? Because that's our left edge. So why don't we go -1, and then what are we going to want to add each time?
The variable.
0.2 for that first one. And we want it to add that each successive time. So we're going to put the variable there, which is usually x, but if you press that key that we're used to using x, what does it give you? N, because we're in sequence mode now, right? Then we go comma, we tell it what variable again, we're using n. Then we tell it how many terms do we want to do. Well, how many rectangles do we have? 20, so let's go from term 1 to term 20. And hit enter.
Did you hit store instead of
No. Too bad. Wait, for midpoint, don't you do in between them?
Yeah, so that's the issue. So I'm just playing around with this and having you guys play around with it. It's good practice. Okay? We may not need it for like this class, but it's good practice, good stuff to know.
Mine comes
So,
up different.
did yours come out different? What'd you get?
No, I like the setup. Yeah, like the setup. I don't get.
Well, for the midpoint,
Where
would
to
you
put
just
things in.
would you do like negative
No, like she can't even
0.95 plus 0.2 to do that with my calculator?
Just go down your list.
Because that when you do the 0.9,
But when I put in the like, I put in all of the ones like you did,
You
and
gotta
then
do this.
yeah, you don't want to do it yourself.
Only stored it.
Oh, it won't, huh? So yeah, 1.1. No,
There's a plus in there.
that makes
Store
sense.
-1. Plus. You notice if you paste, you can fix it. I got that one too. I'll look at it later. Don't worry. Okay, is this right? Are those the midpoints?
No.
Let's think about the very first rectangle. This is what these guys already got. So the very first rectangle, that edge is -1. If it's that wide, then this edge is -0.8, and the midpoint should be.
Negative.
So you got to do a little bit of thinking. Is that right? That would be the right-hand sum, wouldn't it? So that would be if you wanted it as a right-hand thing. So I just like to look at my first thing and see if it's correct, and then I can probably assume that the rest of it's correct. So that would be good for the right-hand thing. How could I modify this and get the midpoint? Can anybody help me? I think there's lots of ways. Let's try it again. Second entry. I think I need to modify that sequence a little bit.
Do you start at -0.9?
Let's try it.
That'll be right.
Remember, you can hit insert. You can hit second delete, which inserts if you don't want to overwrite stuff. Let's try that. Did that give us -0.9 as our first thing? It's closer though. Isn't -0.7 for our next rectangle that we're thinking of right here? Isn't -0.7 in the middle of that one? So we're close. Very good suggestion, Allison. How can we fix it a little bit better? -1.1. So you need to be able to play around with this stuff. This is stuff that really matters. This is what, even if you don't use Calc in your career, this is the kind of stuff that matters. You need to be able to figure this stuff out. This kind of reasoning is so important. Oh. I'm just going to start over. I'm going to start over. So I'm going to go second list, ops, sequence, because I'm getting confused by doing it that way. -1.1, like Caitlin said, plus 0.2 to the n, comma n. I want the first 1 through 20 terms. There we go. Amazing. Now you can take all these. Do you want to go manually enter them into your lists? No. Store.
Answer store.
Yeah, just hit store in your list 1.
Oh, that's what
Now they're in list 1. So I'm going to clear out these other ones again. Ooh, I'll leave that. Oh, is that right?
No, because it's 0.2.
How wide are our rectangles going to be? 0.2.
Is there a quicker way to say 0.2 for all of that?
To all of those?
Because,
Of course there is. Let's think about
because I
it.
kept on trying to get
Let's
it
think
to
about
work
it for a
and
second.
it
Now,
wouldn't.
what are we going to put up here? Remember, we want to get the how high they are. How high are they on this function? What's the function? 3 to the x? So we're going to go 3 to the list 1. That gives us all our y's. Look how fast it does it. Even though there's 20 things, it's no time. Now, Caitlin was saying, I don't want to go put 0.2 for all those widths in, so how can you do that?
You do like 0 times list 1 plus 0.2.
You could 0.2 store in list 3.
That's a good idea. These are good ideas.
I
Good
tried
ideas.
to put 0.2, but it wouldn't work for that.
Highlight the list. How about this? There would be another way to do it too. I'm sure there's other ways. But we just did sequences, right?
Yeah.
So let's highlight the list and drop a sequence right there. Second list, ops, sequence. See, now it's going to do it for that whole list. Ooh, I don't know how to tell it how many. Oh, yes, I do. Yes, I do. Let's see.
You do like 0.2, comma 20.
Shouldn't we do 0.2 and then like 20 of those? Exactly. Nice. So is there any n in there? 0.2. We better put an n right here, just in case I'm betting. And then go 20 of them, and it'll do.
Oh, I got it.
Ha! It worked.
Oh, and then
I bet there's other ways too.
Mine didn't
How's
work.
faster, right,
That
Caitlin?
didn't work either.
What?
I got an
Faster.
error.
That is
Especially if you have
except
a
for 2
thousand.
work for me.
I did 0 times one of the first lists and then plus 0.2.
Does that work too?
That'll come out 0.9.
Nice. Nice.
To the end.
I got an error when I tried to do.
I can't keep a straight face.
Okay, we'll work on this because we'll have some time in class, so I'll help you with this kind of stuff. And remember, you don't have to always do this many. You can do it by manually if you want to. I won't give you ones that are too big. Okay, if you're having calculator issues, talk to me about it in the next few days. So we'll have some time, okay? I don't have time to do it now. So we're going to go, what are we going to do again over here?
L2 times
L2 times L3. Why? Because I don't care that that's what you remember. What does that mean?
They're really
He's on the seat. He's
It's the
What's L2 times L3 mean, Cassidy?
It's the area of each rectangle.
Excellent. Thank you. So then we've got that, and we add them up, right? So we go second list. Now, you might not be, let's say you guys get a, I don't know, a job doing whatever. You might still actually pull out your calculator at some point. I've seen people do that. But you're going to be using software. My point to you is that software usually has the same kinds of functions embedded in it. They might be called something slightly different, but they're always there. Okay? So it looks like that's what we got for an estimate. Now, what do you guys think? When we did it with 20 rectangles on this problem, and when we do it with 40 rectangles, which one's going to be closer to the real answer? Remember what we did yesterday at the end? As you increase the number of rectangles, or you shrink the size of each subinterval down to 0, you take the limit, you get a lot better approximation, right? That's what we saw yesterday. So let's go ahead and do that one. I'll give you guys a second. Try to do M40 with your calculator like we just did. So you might have to play around with it a bit. I'll give you a second. This experimenting stuff is time well spent.
Like, wow. I was thinking a lot into a friendship.
That was a lot of wasted time.
Yeah, that was a lot.
Like 6 years.
It's almost 6 years.
So it's 0.1 every time.
How are you starting?
I couldn't even get the other one right.
I'm trying to get the sequence. I'm trying to remember how to do the sequence correctly. Oh, we're only doing mid. Okay. So
Same thing, just more rectangles. You're going to have to enter a new sequence, yes.
What is the new
Figured
sequence?
Remember, you want to remember how we pictured this. This is the kind of stuff you need to do for
So each
yourself.
one's
Picture
different.
what you're actually supposed to get, and then experiment. So picture for the new one, what are those first two rectangles supposed to be?
Wait, one.
Supposed to have -1, and what's supposed to be here?
Negative
0.9, and right here on the edges. So the midpoints that we want to be are what?
0.95.
Yeah.
Okay.
So somehow we need to get a sequence that outputs those.
I don't know if the sequence is right.
I'm just gonna have to play. I'm gonna
So we
play.
do this, but we're gonna change that to 0.95 plus 0.1 n, or yeah, just 0.1 n, and that's 1 and 40.
But Kyle's saying it wouldn't do that.
But you don't want to forget about the negative. Thank you.
Oh, excuse me. I need a negative, right?
Yeah.
We're still not enough for numbers and
What?
all
Sorry.
that's here.
So,
Try negative
anybody get that?
Yeah.
Wait, what? Oh wait, is that for a sequence? Yeah. Oh yeah, we're defining a sequence.
Is that right?
Yeah. Wait, that's
It's almost right. It's really close.
Wait, what's wrong with it?
We want
Oh, wait,
0.95 as
we
the
need-
first
yeah,
one.
negative 0.95. Why did you put that in there?
Go like
Do we need to start with like 1.05 then?
Mm-hmm.
See? Remember, this is only one way to do it. We kind of figured this out
Or do we have to
together, right?
We have to redo everything in the sequence.
Second, insert 5. I didn't. Gotta be careful. But here we go. Store it in list 1.
It's just programmed.
And then go from there. You're gonna have to redo your list 3 too, right?
Yes.
I'll leave that to you guys. Oh, maybe I'll do it too. I have to redo list 2 too.
Yeah.
That's easy though. That's just 3 to the 1. And then up here I put something special.
I personally like that one's way better. Which is
Do you?
0 times list 1 plus the point whatever.
It's a nice way too.
I think it's easier.
It's great. So we went like this, right? You went 0 times
Times list 1.
list 1 plus 0.1.
I don't
Yep.
get why you can't just put 0.1 in at the top and have it go through.
Because there's no index for it to count by.
There you go.
How did you manage to put the in Todd's way puts the index in by saying compared to the list 1 value each time. I put the index in by just it's built into the sequence, right? Somehow you have to reference it back to something you're counting by, so it puts it in the right number of times. Otherwise, if you put 0.1 in there, what would happen?
No.
It might go forever, and you'd enter an infinite loop. Technology does not like infinite loops. That's why we had this computer issue the last couple of days. We've had an infinite loop on the internet.
Is that what's going on?
Yeah.
Because it's awful.
Yep. That's the problem. So that's why computers work like this.
Computers are just
What'd you get?
I got a 27.
You got 27. I got 24.26. You're on the second
It should be 24.
list.
Oh, you beat me.
Killing you.
So what did we get for 20? What did we have before?
24.26.
This one's 24.2601,
0.8.
right? We used 3 decimal places. And this one, what did we have before? I forgot.
24.224.
They're both pretty close, right? So on the AP exam, would either one of them be sufficient to get you credit for the integral? This is what we're going to do. Because I remember I said if you increase the number of those rectangles or shrink their sizes, the subinterval sizes down to 0 with a limit, you get the real integral answer. Would that be good enough for the AP exam? Well, let's use our calculator to get an even better one. So our calculator does this a certain way. So if you would go to math, this is big, so we're going to be using this a lot the rest of the year, and it's very easy to use. Your calculator can do integrals for you. It's math option 9.
Whoa.
Some of you it might change to this form. Some of you, if you have 83s, it won't. It's okay though. Notice, it's kind of nice if it goes from here. So what do you guys think I want to put in for these numbers?
We
We haven't done this yet, but yeah, it's the -1 and the 3. It's the edges you want to integrate over. Where do you want to start finding the area? That's what you put at the beginning. Where do you want to stop finding the area? That could be anything, right? For this problem, it could be way over here, a small piece here, a big piece, could be anything. And then you put in what's your function for us? 3 to the... Oh, we need to get out of this mode, right? Go back to mode, change it to function. You should be able to fix that. There we go. If you have an 83, you need to put 3x as your first thing.
Is it 3x or
No, 3 raised dx.
Oh, yeah.
Yeah, there is a difference.
There is a big
No, we
difference.
just do data.
So if you have the old calculator, you're going to go 3x, variable x, and then you're going to put those right there. Okay, for us, where are we going to put that extra x, of course?
After the dx.
The dx, right? That's how we keep track. And it tells us the answer is 24.273. So would either of these have been close enough? Which one's closer?
40. Well,
This one's
makes
closer,
sense.
which makes sense, right, based on what we saw last time, right? This one should have been closer, but that's the real answer. That's still only an approximation. Read what your guide says. It says the fn int option on your calculator is using Riemann sums, because remember, once again, can it handle an infinite number of stuff? No. It's using Riemann sums, but the size of the rectangles is really teeny.
You did for average.
So this is a very good estimate. In fact, I think it's accurate out to here. After that, it might not be accurate anymore. Okay? So it depends on the level of accuracy you need. Okay, what I want us to do now is look at 3, 4, 5. Those should just take us a second. So I'll do 3, and then you guys can help me with the other ones. So 3. I don't think we need our calculator for a second. Oh, maybe we do. So 0 to 2, x squared dx. Let's sketch what that looks like. That's what function, parabola? So it's between 0 and 2. I want this area, don't I? That's the area that we're finding on this problem. So that's what an integral does. It finds area under a curve. You haven't figured that out by now, yeah? So use fn int to approximate that. Very good approximation. See what you get for that area under x squared between 0 and 2. What do you get? There's no way you could have done this. This is calculus.
6. So 2 1/3.
So this is what?
2 2/3, right?
So the calculator was giving you 2.666. So yeah, 2 2/3 is the actual real answer. Amazing.
Yeah.
Do the other ones. So do 4, do 5. See what your calculator gives you on those,
Would it
please.
just be negative 2 2/3? Like, why would you even?
Yeah, it is.
Yes, yes, yes.
Do you remember the thing of that I showed you the documentary yet?
Hmm.
A while ago. He does that, it's really fun.
So 5. What did you guys get? I bet you got 2 2/3.
Negative.
Negative
On number 5 or 4?
4.
Oh,
geez.
sorry, number 4.
I haven't done 5
I'm
yet.
sorry.
Yeah,
Give me a
5's
second.
fine.
And 5 I got.
5 is
I got the
positive
same
2
thing.
2/3 because whether you're on this side of the parabola or under this side, aren't you going to get the same area? It's a symmetric function, isn't it? So it makes sense that the area on those is both going to be 2 2/3. So on number 4, why did you get negative?
Because you're moving from 0 to negative.
It's like you're going
Plus
0
two.
to
No,
negative
plus 2
2.
times.
Are you going from left to right? No, you're going from right to left on number 4. So if you ever integrate backwards,
You'll get the negative.
you're always going to get a negative answer. Does that make sense? That's key. If you you might want to write it down somewhere in your notes, somewhere important. If you integrate backwards, you get a negative answer. It's very easy to know. I mean, it's not a big deal, but
Negative.
it makes sense. Going backwards is negative, yeah? Going backwards velocity is negative velocity, that kind of stuff. Going backwards area turns out to be negative area. Weird.
Oh, no. This is going from negative 2 because this wouldn't go from like this.
Okay. After you've done that, I want you to go flip the page, and I'm going to give you guys 7-8 minutes to do 6 through 11 with your calculator. So do a real quick sketch first. That might take a little bit faster, a little bit longer. Sketch what that looks like first, please. Do the sketches, and then go back and do them all with your calculator. That should take no time.
3 repetitive ones.
Yeah. So I'll maybe sketch the first one with you. So number 6, here's what that looks like, right? I'm sketching the sine function. So sine looks like this. So pi over 2 is right here, right? So that's that area. You okay with that? So if they ask you integrate the sine between 0 and 2 pi, it'd be this part and that part down there. I'll put the answers up on the board in a second too, but I want you to explore those.
Second entry.
Third entry.
Yeah, that's what I've been doing.
Oh, really? Just like we said.
Yeah. It's the same. Yeah.
I'll do a couple of them. Let's see. Any of you watching the video should also be making sure that you do all those by yourself. I'll check a couple of them up here. Number 8. So are there ways to do these without the calculator? Oh yeah, they're easy.
Yes,
Not
it's
a big
just
deal.
after you've done two. Obviously.
You about ready? We have number 7? What is 7? Is the answer. The calculator's integrator. Remember, calculator's using rectangles still. It's not really doing an integral, but it's giving a very good x. It says it's basically -2. So why do you get -2 for that?
Because it's coming from.
Look at that
two
area.
heights.
Why is that considered a negative area?
The way it's y.
It's below the axis. So something about being below the axis is negative in terms of area.
It cancels it if it's also going.
So we're trying to think about how integration really works here, okay? So I'll write the rule down in a sec. It's not a hard rule, but okay. So if you do that, if you're below the axis, looks like you get negative area, yeah? This guy up here, you had some positive area then and some negative area. I think those are the same exact size for a sine function, so what should that one be? Because they like cancel each other out. In fact, this one is size what? -2, and you can bet that one's then 2, so they cancel and you get 0. Number 10, looks like you've got a negative area. Did you guys get a negative answer?
No, because you're going from 2 pi to pi.
It's 2, right? Why?
Because you have negative.
Because they didn't start integrating at pi here and go pi to 2 pi and do it normally. They said, okay, pretend you're going backwards and start there and start adding your rectangles up in that direction, which is the negative direction. So negative is positive. Okay. So now it says to write your conclusion kind of down at the end. You know what? Let's just write this real simply. I think that we've learned what integration really means now, or one of its meanings. So integrals. Did they just give you area? We've learned they give you area, right? But what kind of area?
Approximate or radian, whatever.
Well, so far we've been doing them approximately, you're right. But they give you net area. They don't just give you like plain old area. They give you net area. What is net area?
After it changes them.
It's the area above the axis, the x-axis, right? But it's the area above the axis. Net always has minus in it, right? Net profit, net anything, minus the area below the axis. You'll see that's a pretty big concept of this course. It's not a bad concept, but it's true. That's why we got, on this problem, was there any stuff above the axis? No, so we just got the below. So we just got the minus how much is below, and how much is below is 2, so minus 2. On this problem up here, we had above was like 2, below is 2, 2, but 2 minus 2 is 0. 0. 0. Sounds like a cereal. It's a cereal.
I think it is a cereal.
Zeros.
Here it is.
Okay, here's a couple other examples. I'm going to do like 2 other examples to help you out with this assignment. Maybe a few more. So, some problems on your assignment are going to ask you to evaluate the integrals, and they're going to ask you to do it with a picture. And this is big. AP likes these kind of problems, and they're not hard problems either, is the nice thing. So let's do that one. Let's use a picture to do it. They say geometrically. Do these geometrically. Let's do that one geometrically, and let's do this one geometrically. okay? And then I'll maybe do one more example. Got a lot today, and that should be it. I think the hardest stuff we already did, though. The hardest stuff probably for the rest of the year was that using your calculator to do like the sums. That might be a little bit tricky on some. But these aren't too bad. Watch. Okay. What function is being inside here? If we draw it, what's it look like? It's a line. How high? 3. 1, 2, 3. There's your function that they're talking about. Where do they want you to look at it? Between 2 and 5, right? So they want you to come over here between 2 and 5. And what's that sign mean? We now know that symbol's meaning. It means what?
From 2
An integral is area under the curve, right? So that's the curve. Between 2 and 5, the area under the curve
3 times.
looks like this, which is this time a simple rectangle, which the area is what, Brett?
9.
It's a 9? Agree with him? It's 3 high and 3 wide, so yep, 9.
Square.
So some integrals you can do like that. Is there a faster way to do these than drawing? Yes, but we haven't done that yet, okay? You'll like that way. But I think it's really important to understand that how to do these geometrically, and so does AP. They agree with me. I'm glad. 2x, what's that look like?
It's a line, but it's like 2, like a slope of 2.
Yeah, slope of 2, intercept of
Origin.
0, so go up 2 over 1. Draw plain old, I should draw it in blue to be consistent. Yeah, it's that line. There's 2x. Where do they want us to look at the area under the curve? From 0 to 2. They could have asked us anywhere, right? Like it's totally legit for them to ask us anywhere. But they said between 0 and 2, which looks like it's only going to be positive area, right? So be careful. Some of these problems will certainly have negative parts. And if they have a negative part and a positive part, you've got to...
Yeah, it'd be 4.
Add them.
Let's go ahead and change this problem. Let's make it a little harder. Let's go from -1. Okay? So now I'm going to go from over here, right? So that means I'm going to have to also do, that's the area under the curve over there, isn't it? I know it kind of is like below, but remember, it's not really area under the curve, it's net area. It's area between the curve and the axis. Okay? So what does that equal
The
to?
area of the top is 4.
So how'd you get the area of the top then?
1/2 base times height.
How'd you know this went up to?
Because 1 is 2, and then 2 would be another up 2.
So you can count. You could also just plug this into the function. When you plug 2 into the function, what do you get? 4, so that's up at 4, so that's 4 high. This is 2, so the area here is, what's the area of a triangle? Half base times height for that triangle, and we've got another triangle, don't we? Should we add or subtract the other one?
Subtract.
It's going to be negative, right? Because it's below the axis. So -1/2. How wide is that? 1. And how tall? We better be careful.
-2.
My picture might not be perfect, right? If you plug -1 in, you get, this is -2. So I'm just going to go, the negative's already kind of in there. So 1 times 2. Okay. So notice, really, the negative kind of tells you this -2. That's another way to think about it. And we get
3.
8 over 2 minus 1 is 4 minus 1 is 3. That's the integral. Okay, you guys liking this? Pretty neat, isn't it? 3. The question is, those ones were a little easy to recognize. Now, I, with your class, did not do enough of this still. So maybe this isn't quite so easy to recognize. What shape is that, though?
Like slow growth.
What is this? You're thinking square root function.
But it's actually, it's 2 minus.
Isn't it like this? Go backwards.
It's a circle.
Okay, that's a circle. We remember it. That's the top half of a circle, right? Because it's just the plus square root. If you had the minus square root, that'd be the bottom half. No, I'm sorry. I didn't do quite enough of that with you guys. What's the radius of that circle?
2.
2. So we're going to go out 2. This is only the top half because it's only the plus square root. Minus half would be the bottom square root. So we know that the curve looks like this. Yeah. And we're just going to integrate it. Oh, look at that.
They want the
They made it nice for us, didn't they? Could they have said -1 to 2? Yep, and guess what? We'd be out of luck doing it as a picture anymore. We'd have to go to the real integration stuff. We could do it, but not in this lesson. So we want that. What is that area?
That's half of pi r squared.
Half of the area of a circle, pi r squared. Half of pi, what's the radius?
2.
2 squared. It's that. So that is 4 over 2 is 2 pi. So the integral is 2 pi exactly. That's not an approximation, that's the exact answer. We need these exact answers for all kinds of reasons. Approximate's usually not good enough. Okay, so you've got some geometric problems. If it says do it geometrically, do it that way. And then there's a couple problems that are easy, kind of two that give it to you in another way. I'm just going to do maybe one. These are kind of dumb, but you know how to do them. So let's say they give you stuff. Let's just say they give you stuff, all right? Let's say they say between 2 and 4, x squared is 20. So far, is x squared a shape that you know? It's a parabola, right? But is it? Do you have the area formula for a parabola? No, we couldn't do that till this class. Now it's real easy to do, it turns out. But let's say they just give you that. And then they say, okay, and also between 2 and 4 of just x, we could do that with a picture, but we would get 6 if we did it with a picture. Okay, you can confirm that if you like. So now they say, okay, what is the integral between 2 and 4 of 4x squared minus 5x plus 3
Wait, is that
dx?
middle step x squared?
Where?
So to the right one, the top right, is that just x or x?
It's just x.
Okay.
So they gave us x squared, that function between there, and this function between there, 2 different functions. Okay. So if they did that, can we use that information to do this one now?
Yes.
How?
You could plug it in.
We can plug them in. How are we going to split this up though?
Or
Please.
integral x squared.
Nice.
Plus
4 integral x squared, you're telling me this, right? Plus, go ahead, Cassidy.
5.
Minus or plus?
Minus. Or is it? I don't know. It's obviously plus.
Isn't this a minus?
Yeah.
So I'm going to go minus 5. Pull that out though, you're pulling it out. That's good.
Disappointingly.
Oh god.
You're fine.
Plus integral 3.
And you could go just 3 times 1 dx, or leave the 3 in, it's up to you, right? So then you go 4, and then what should I put on both these, all these integrals that we didn't do before? The limits, these are called the limits of integration. We'll become very familiar with them. They're not a big deal to worry about, they're easy. Sometimes you have indefinite integrals, sometimes you have definite integrals, so we're moving in the definite direction. Okay? This one is, of course, 20. Minus 5 of those, how much are those? Those are 6. Plus 3 of those, how much are those? Now, they didn't tell us that, but what are those? You have to draw, right? So that's a function that is 1 high, between 2 and 4, between anywhere. How much area is in there? Yeah. You could have left the 3 inside and done it 3 high, and just like we did that other one, it's up to you. Anyway, easy, right? 80 minus 30 plus 6. 36. So we're kind of still skipping around this issue of when you have a definite integral, how do you really do it? We're doing it with pictures, we're doing it with approximations on our calculator. Before we leave for break, we'll finally do the last lesson we do where I show you how to do it for real. Okay, and it's not a big deal to do it that way. Okay, there you go. Our assignment is this.
And this is due.
I have not decided.
Sweet.
That's a good answer.
That's a fair.
It's not like the answer I like
No.
today.
I think we can probably deal with just working on this week.
Okay.
That's a fair time.
So will we have time to work on it Thursday?
Yes. You want to start though? You can ask me stuff.
Those of us with play practice are grateful.
I'm trying to be nice. I gotta say though, I'm gonna be kind of sad if everyone drops. It'll be upsetting. It will, especially since most of you are gonna pass this test. Can't say for sure, but
in your heart.
a couple of these I have special instructions. I think you'll like my instructions better on these ones. These are actually pretty easy integrals, but let's just practice using fn int on our calculator to do those ones, okay? And let's see, anything else? Oh yeah, these are like midpoint guys, just like the ones we did today, so let's use the lists. Midpoint list stuff like we did today, use those, okay? You're not gonna like the books way better, so. So we'll say let's absolutely do Monday. But start it, keep going on it.
My mom makes scones every now and then, and it's the most amazing thing ever.
I threw up after eating scones, so now I just can't.
Brett, Oliver, will you not tell us that?
That's like my brother in pork steaks now. He got terrible food poisoning while we were in St. Louis and pooped everywhere. It was disgusting. Because we had to share a bed, a king size bed, and he just all over his side. It was a nasty scene.
I probably would have
He like
moved to the
walked
floor.
down the stairs and he's like tired, like and he stood at the door. There's a door at the bottom of the stairs. And he like stood there because he couldn't find like the door knob because it was dark.
Yeah.
Standing there.
Scott?
Yeah. Then literally there was poopy footprints to the bathroom. It was the most disgusting
So you wake up in the morning and see all that?
No, I
Oh.
woke up when he woke up, and he gets out of the bed, and I just looked, and there's just a huge brown spot in his bed. I was like, oh my god. Oh my god.
How old
What
is
is
he?
the hour?
It was probably about 4 years ago. He had like the worst food poisoning ever.
No, that was pretty bad.
Did you poop and make poop footprints?
No. Did you give birth to like a fetus?
I don't want to know any more about this situation.
This is really
You
gross.
didn't do that. I think
No one
you
else
know-
does either.
I think you just need to go to the doctor.
Yeah.
It's called oversharing, boys.
Did you show him his ring?
No, he doesn't need to see it.
He doesn't need
I don't want to see anything you're filming now.
How many
I'm just scared.
Conversations.
like you had 8?
She said you had 8.
No, I had about 4.
Can I go to the? I was handing out the first one, but like so confused.
Wait one sec. Let me write down these things.
You just count up the shaded